right, listeners, get ready, because today we are diving deep into Amazon DynamoDB. You guys send in a ton of great material from the Cloud Guru DynamoDB guide, and honestly, I'm already excited. Just skimming through, I saw mentions of global tables, the document model, and even something called DAX, which sounds intriguing.
Yeah, those are some of the core components that make DynamoDB so powerful. And this deep dive is going to be perfect whether you're completely new to DynamoDB or just want a refresher on how it all works.
Perfect. So to set the stage, DynamoDB is essentially a NoSQL database service offered by AWS, right?
Right. And what makes it stand out are those keywords you mentioned earlier: serverless, fully managed, and that promise of single-digit millisecond performance at any scale.
Okay, stop right there for a sec. Single-digit millisecond performance at any scale. I mean, that sounds almost too good to be true, doesn't it?
Well, it's the reality of these modern cloud databases. Serverless simply means you don't have to manage any servers yourself. AWS handles all of that behind the scenes, and fully managed takes it even further. AWS takes care of things like patching, backups, and even scaling the database as your needs change. You can just focus on building your application.
So that's where the speed comes from, by taking all that overhead off our plates.
Exactly. DynamoDB is designed from the ground up to handle huge amounts of data with incredibly fast response times. And the best part is that performance stays consistent even as your application grows.
Okay, I'm already starting to see why people get so excited about DynamoDB, especially if you need to build applications that are super responsive. But before we get too far ahead, let's take a step back and look at the fundamentals. How does DynamoDB actually work? What are the basic building blocks we need to understand?
At its core, DynamoDB is all about tables, items, and attributes. Think of a table as a container that holds a collection of items. Each item represents a piece of data, and attributes are the specific details within each item. Like, imagine a people table.
Okay, yeah, I can picture that. So like a spreadsheet where each row represents a person, and then you have columns for their name, address, and so on.
You're on the right track. But remember that DynamoDB isn't limited by rigid rows and columns like a traditional spreadsheet. It gives you way more flexibility. So in our people table, each person would be an item with attributes like personality, last name, and even more complex attributes like address, which could itself contain nested attributes like street, city, and ZIP code.
So there's structure, but it's more adaptable to different kinds of data. I get it. Now, for someone who actually wants to work with DynamoDB, how do we access and manage this data?
Well, for starters, there's the AWS Management Console. It's a web-based interface, super user-friendly, great for visualizing your data.
So point and click to create tables, add items, that sort of thing. Sounds perfect for getting started. But I noticed the guide also mentioned something called the AWS Command Line Interface, or CLI. Is that more for advanced users?
Yeah, the CLI is great if you prefer working with a command line interface. It gives you a lot more power and flexibility, especially for automating tasks. You can interact with DynamoDB using code, essentially.
Okay, so two main ways to interact: the visual approach with the management console and the code-driven approach with the CLI. Both sound pretty useful. Now, I'm curious about some of these core DynamoDB concepts that make it so unique. Let's start with data consistency. The guide talks about eventually consistent and strongly consistent reads. Can you break those down for me? Why should we care about this difference?
This is where it gets interesting. It's all about finding the right balance between speed and accuracy. With eventually consistent reads, which is the default in DynamoDB, you're basically getting the fastest possible response. But there's a slight chance that the data might not reflect the absolute latest updates.
So it's kind of like checking your email. Sometimes a new message hasn't appeared yet because it hasn't quite synced.
Perfect analogy. But if you absolutely need to be sure you're seeing the most up-to-date information, you can choose strongly consistent reads. It might take a tiny bit longer to retrieve the data, but you're guaranteed to have the latest version.
Got it. So if I'm building, say, a stock trading application where every millisecond counts, I might prioritize speed and go with eventually consistent reads. But for something like bank account balances, where accuracy is paramount, strongly consistent reads would be the safer bet.
Exactly. It's all about choosing the right consistency model for your specific needs.
That makes sense. Now, I know that reading and writing data comes at a cost. How does DynamoDB handle that? The guide mentioned something called capacity units.
Right. Capacity units are essentially a measure of throughput, or how much data you can read or write per second. And DynamoDB offers two main capacity modes to choose from: on-demand and provisioned.
On-demand sounds pretty straightforward. You just pay for what you use.
Okay.
Precisely. It's like paying for your electricity, you only get billed for the amount you actually consume.
And provision capacity.
With provision capacity, you pre-allocate a specific number of read and write capacity units. This gives you predictable costs, and it ensures you have the capacity you need, even during those peak usage times.
So if I have a really popular e-commerce site with consistent high traffic, I might lean towards provision capacity. That way, I can be sure my application can handle the load, and I know exactly what my costs will be.
You got it. On-demand is great for unpredictable workloads, or if you're just starting out. But for consistent, high-volume applications where predictable cost is important, provisioned capacity is often the better choice.
I'm already starting to see how these different capacity modes can be tailored to specific use cases. This is giving me a much clearer understanding of how DynamoDB works, and we've only just scratched the surface.
You're telling me. There's a lot more to uncover. Next up, we'll dive into some of those more specialized features.
Okay, we've covered the basics. Tables, items, attributes, capacity modes. Now I'm ready to explore those specialized DynamoDB features you mentioned.
Great. Let's start with data modeling, which is super important when working with DynamoDB. It's different from those relational databases you might be used to.
Yeah, I'm starting to see that. So what are the key differences we need to keep in mind? How do we approach data modeling in this NoSQL world?
In relational databases, you've got a fixed schema right from the start. But with DynamoDB, it's more flexible. The design can evolve as you go. The trick is to understand how you'll be accessing your data before you even think about tables and attributes.
So instead of just diving in and creating tables, we need to step back and ask, how will this data be used? What questions do we need to answer?
Exactly. Let's say you're building an e-commerce site. Will users search by product name, by category, price range, maybe a combination? Answering these questions up front is key to a good NoSQL design.
Okay, so it's not just about storing the data. It's about storing it in a way that makes it easy to find and use later, which is where those partition keys and sort keys come in, right?
Yep, they're at the heart of how DynamoDB organizes data and retrieves it efficiently. Think of the partition key like the primary address for your data. It decides which physical partition that data will live on.
Like a street address, getting us to the right neighborhood. But what about the sort key? What does that do?
The sort key brings order within that partition. Let's stick with our e-commerce example. We could have a partition key of product category and a sort key of product name. This means all products in the same category are grouped together, and then within that category, they're sorted alphabetically.
So if I want to find all the books, DynamoDB can zoom right in on that category and quickly go through the book titles in order. Makes sense.
Right.
But what if I want to find all products released in, say, 2023, regardless of what category they're in? That's not covered by our existing partition and sort keys.
That's where secondary indexes come in. They're like alternate pathways to your data. They let you query on attributes other than your main keys.
So instead of being limited to just one way of finding data, we have options. That's the flexibility we were talking about. Can you give me an example? How would a secondary index work with our e-commerce data?
Sure. Imagine you want to find all products released in 2023. You could create a release date index, and that lets you quickly find those products without having to scan the whole product catalog table.
I like it. We can have multiple indexes, each one tailored to a specific type of query. It's like having a custom library cataloging system. Now, I remember the guide also mentioned some really cool features like DynamoDB streams. What are those all about?
Streams are all about real-time updates. Imagine you need to know instantly whenever data changes in your table. DynamoDB streams provide a constant feed of those changes, things being added, updated, or deleted as they happen.
Okay, so it's like a live stream of any activity in the database. Why is that so useful? What kind of real-world scenarios would need that?
Tons of possibilities. Real-time analytics, triggering actions in other systems, even building whole applications around those events. Like, let's say, every time a new product is added to your e-commerce site, you want to update the search index immediately. Streams can handle that.
Wow, that's really powerful. It's like a chain reaction where one change of the database automatically sets off other actions. But what about situations where you need to make multiple changes to the database as part of a single operation? Does DynamoDB have anything like transactions to make sure everything stays consistent?
Absolutely. DynamoDB supports transactions, which means a group of operations either all succeed or all fail together. This is critical for keeping your data consistent, especially in applications where accuracy is super important.
Give me an example. Where would transactions be essential?
Let's go back to that e-commerce example. Imagine a customer places an order. You need to update the inventory, add the order to their history, and update the shipping info. If something breaks in the middle, you don't want to end up with incomplete orders or messed up data. Transactions ensure all those actions happen together or not at all.
Okay, now that makes perfect sense. Transactions add that extra layer of reliability. So we have streams for real-time updates, transactions for data integrity, and then there's this DAX thing.
Ah, yes, DAX, or DynamoDB Accelerator. This is where things get really exciting, especially when you need super fast reads. Think of it as an in-memory caching service that sits in front of your DynamoDB tables.
So it's like a high-speed shortcut for accessing data that's frequently needed. Is that a fair way to think about it?
Exactly. Imagine you're running a social media platform with millions of users checking their news feeds constantly. Those feeds are generated by pulling data from DynamoDB. With DAX, the most popular data, like trending posts or updates from close friends, are kept in memory for ultra-fast access.
So instead of going back to the main database every time, the data's right there, ready to go.
Yeah.
That must make a huge difference for user experience.
It does. DAX is a game changer for real-time applications, social media, gaming leaderboards, any situation where even a millisecond of delay matters.
This is incredible. So how do developers actually work with all of this? How do they interact with DynamoDB from their code?
That's where AWS SDKs come in. AWS provides software development kits for a whole range of programming languages. These SDKs act as a bridge between your code and DynamoDB, offering a convenient way to interact with the database without having to deal with the low-level details.
So whether I'm a Python person or a Java fan, there's an SDK that lets me talk to DynamoDB.
Exactly. And the best part is that these SDKs are constantly evolving, getting new features and improvements all the time. And it's worth mentioning that DynamoDB also offers different programming interfaces to suit various needs and preferences. We have the low-level API for those who need that granular control, and higher-level interfaces, like the document API, which provides a more object-oriented approach.
Okay, so options for both the close-to-the-metal folks and those who prefer a more abstracted, user-friendly approach. That's great. But before we get too deep into the technical side, let's not forget about security. How does DynamoDB keep our data safe?
Security is absolutely essential, and DynamoDB has some serious security measures built in. All data stored in DynamoDB is automatically encrypted at rest using keys managed by the AWS Key Management Service, also known as KMS.
So even if someone were to gain access to the physical storage where that data is kept, it would be useless without those encryption keys.
Precisely. And when it comes to controlling who can access your DynamoDB resources and what they can do, you can leverage AWS Identity and Access Management, or IAM. This lets you set granular permissions for users and applications, making sure that only authorized folks can access sensitive data.
This is starting to sound like Fort Knox for our data. Encryption to protect the data itself, and IAM to control who has access.
It's a multi-layered approach to security, designed to give you peace of mind. And just like everything else with DynamoDB, it's super customizable to fit your specific security needs.
Wow, this is an impressive array of features. We've gone from the basic concepts of tables and attributes to advanced features like streams, transactions, and DAX. We've even touched on programming interfaces and security. I'm starting to get a real sense of just how powerful this technology is.
And believe it or not, we've only just scratched the surface. There's so much more to explore in the world of DynamoDB. But I think it's time to step back and see how all of this is being used in real-world applications.
I'm definitely ready for that. The guide mentions everything from financial services to serverless applications to gaming leaderboards. Let's dive into those next.
Okay, so we've spent a good amount of time digging into how DynamoDB works, all its cool features. But now I'm really curious, how is this being used out in the real world? The guide mentioned everything from financial services to serverless applications to even gaming leaderboards. Yeah, there's a huge range of use cases. Why don't we start with financial services?
Sure.
So DynamoDB is perfect for financial services because it's so fast and it can scale like crazy. You need that when you're handling massive volumes of transactions in real time.
Right, like a stock trading platform where every millisecond counts.
Exactly. Or think about banks processing millions of credit card transactions like every second. That's where DynamoDB really shines.
So DynamoDB is literally powering the systems that keep our economy running. That's pretty mind-blowing. The guide also mentions serverless applications as a good fit for DynamoDB. What makes it such a natural pairing?
Well, serverless is all about flexibility, scaling on demand, and only paying for what you use. And DynamoDB aligns perfectly with those principles.
Right, because it's also serverless.
Exactly. So you can combine DynamoDB with services like AWS Lambda and build really powerful applications without having to manage any servers yourself.
So you get all the benefits of a managed database service like DynamoDB, but without the headache of setting up and maintaining your own servers. Okay, last but not least, we've got gaming leaderboards. How does DynamoDB fit into that world?
Think about a massive multiplayer online game, like millions of players competing for those top spots on a leaderboard. Those leaderboards need to be updated instantly as people are playing and scoring points. And they need to be accessible to everyone with like zero lag.
Yeah, you can't have players waiting around for the leaderboard to refresh.
Exactly. So DynamoDB is perfect for this because it can handle those massive amounts of data. It provides super fast read access, and it can scale to handle like millions of users at the same time.
Wow. So whether we're talking about tracking billions of dollars in transactions, building those super scalable serverless apps, or fueling the competitive spirit of gamers around the world, DynamoDB is there, quietly powering it all. It's incredible how versatile it is. But I imagine with all this power comes a certain level of complexity. Are there any common pitfalls to watch out for or best practices that are essential for success with DynamoDB?
Definitely. The Cloud Guru DynamoDB guide actually has a whole section dedicated to best practices, covering everything from how to design your tables effectively to managing your throughput and making sure you can handle errors smoothly. It's worth a read for sure.
So it's not just about knowing which buttons to press. It's about using those tools strategically and thoughtfully to build a system that actually works well.
Exactly. One of the big things to remember is to really embrace the NoSQL mindset. Don't try to force DynamoDB to act like a relational database. Remember those access patterns we talked about earlier? Well, thinking about those up front and designing your tables around them is key to success.
Got it. So it's about working with the unique characteristics of DynamoDB, not against them. It's been fascinating, starting with those basic building blocks and going all the way to real-world examples. I feel like I have a much deeper understanding of what DynamoDB is all about now.
Me too. And for anyone listening out there, I think the big takeaway is this. As you dive deeper into DynamoDB, don't be afraid to get creative. Think beyond those typical use cases. What unique challenges can DynamoDB help you solve? What kind of game-changing applications can you build with it?
I love that. It's about embracing the creative potential of this technology and finding new and exciting ways to apply it. Well, this has been a truly insightful deep dive into DynamoDB. Thanks for joining me on this journey.
My pleasure.
And for our listeners, until next time, keep diving deep and keep exploring that incredible world of knowledge.